Hello, everyone. This is Emmanuel from Cornell, and this talk is about exploiting foundation models for natural language processing in order to make data profiling more efficient. Because data profiling is typically the first thing that we want to do when working with a new data set. We want to find out what are the value distributions in columns, which columns form candidate keys, and what are the correlations between different columns. This knowledge is useful for adding constraints to our database schema and for making good query optimization decisions. Now, there has been a lot of work on data profiling. Typically, it is assumed that we have some kind of time limit for profiling because profiling is expensive. And that motivates us to prioritize analysis during profiling in order to find out as much as we can about a data set until time runs out. Now, typically, it is assumed that we start data profiling without prior knowledge about a data set. But for instance, if I'm downloading the data set that you see here, which is a table about cars with columns for the car maker and car model, for the year, as well as for the license plates, then I can already make some educated guess about certain data properties just based on the column names. For instance, I can assume that the year column will have a small number of distinct values of type integer. I can assume that the license plate column will contain unique values, and probably there is some kind of correlation between the car maker and the car model. All of those assumptions are based on the column names as well as potentially accompanying text and some common sense knowledge. So I was recently wondering whether we can automate this kind of reasoning, and the foundation models for natural language processing seem to offer an opportunity here. Those are large neural networks that are, first of all, trained in an expensive pre-training step where we use some kind of task for which large amounts of training data are easily available. For instance, trying to predict obfuscated words in a web text. And then we can specialize those models to other natural language processing tasks with relatively moderate overheads. For instance, I have recently specialized one of those models in a process called fine-tuning in order to predict the likelihood of correlation between column pairs based on the column names alone. So I'm thinking about using this kind of approach in order to prioritize analysis operations in data profiling. And I made some first experiments in this direction. So the goal is to find correlated column pairs according to different metrics of correlation using a benchmark set with around 4,000 tables downloaded from a Kaggle. So I'm comparing a baseline which analyzes column pairs in random order to an approach that uses a fine-tuned natural language model for predicting the likelihood of correlation between column pairs based on the column names, and then analyzing column pairs first if they have a high predicted likelihood of correlation. Now, here you see a representative extractor from those experiments. On the x-axis, we have the profiling budget, and on the y-axis, we have the percentage of correlated column pairs that the approach has found. And when comparing to the baseline, we find significantly more correlated column pairs when prioritizing columns that have a high predicted likelihood of a correlation. You find the code for those experiments on my GitHub repository. Of course, those are just some first proof of concept experiments that validate the idea that the information we gain from natural language processing on schema names can be helpful in order to make profiling more efficient.